Alrighty, so if you guys notice, these problems that are in this video help are quite different from the ones that you did for practice. And so what I'm going to do is I'm first going to review the general concept of the different types of synthesis reactions, and then I'm going to help you go through these because these are a little bit more, possibly more challenging. They just really require you to think, but they are a fair game for a quiz or a test. So there are three different types of synthesis reactions. In a 1A, what happens is you take one element, okay, and you add a second element to it, and what you get as a result is one compound that is a combination of A and B. Okay? For 1B, what happens is you take a metal that is bound to oxygen. So there are not an infinite, but there are tons of different examples. You could have Na2O, you could have MgO, you could have Al2O3, you could have any metal oxide. And if you add water to it, H2O, so you've got to have H2O, you're going to form a base. Okay? And so on your little cheat sheet, which you'll be given, it just says base. Well, I'm not going to write base here. I'm instead going to write the formula for a base, which is something that you're responsible for. All a base is a metal that is bound to hydroxide. Okay? So remember, the important thing for these two different types of synthesis reactions, the A and the B, the 1A, the 1B, you have to cross your charges. Cross charges. Okay? So when I am making, hold on one sec. When I'm making my AB, I've got to cross my charges. If I ask you to make this, okay, your MO, your metal, and your oxygen, to make that brand new compound, you have to cross your charges. To make your metal and your hydroxide, you have to cross charges. The last one is a 1C, and in a 1C, it's actually super easy. All you have to do, you have a nonmetal and oxygen, so you got a nonmetal oxide. It could be SO2, SO3, CO2, NO3, NO2, anything. You add water to it, and what you'll get is an acid. Okay, and so in that little cheat table, it just says acid. What you need to know is that an acid starts with an H, then you've got whatever nonmetal you're dealing with, and then if you have it, you'll put oxygen after it. Okay, so hydrogen followed by the nonmetal followed by oxygen. The important thing for you to know for this one, the reason why it's different from 1A, 1B, the reason why I put it in red, is because this is a balance as you go. Balance as you go problem. Okay? So I'm going to show you what that entails, obviously. So I'm going to do this first problem. And what you notice is that normally I ask you to write the products, but all of a sudden I'm asking you to write the reactants. So what you should see is I've got a blank plus water, and then as my product, I've got a base. I've got NaOH. So since I made a base, since I took two things, combined them together to make a base, that tells me automatically I've got a 1B. Now the important thing for you to realize is say, okay, well, obviously my metal in this case is sodium. It's Na. And so what I need to do is I need to combine Na with O to create my metal oxide. Remember, whenever I form a brand new compound, that is an ionic compound, which this is, I need to cross my charges. And so I've got Na here, and the charge of Na is always +1. I've got oxygen, which I'm combining with it, so it's 2 minus. And so when I cross my charges, what I get is Na2O. So this is a brand new way of looking at this problem because before this point, what I did was I said, oh, okay, you've got Na2O. You add water to it. And your product is going to be what? And so at that point, what you did, I'm kind of just doing the reverse to show you how it's super similar, except I'm just reversing the process. I say, okay, I need a base. A base is my metal, which is sodium, Na, with a +1 charge, and hydroxide, OH, with a -1 charge. And so what we did up until now is say, well, okay, obviously this is now just going to be, since I crossed my charges, NaOH. So it's super nice and easy. And what you should realize is I can go either way. I can ask you to write out my reactant that I start with, Na2O. All you do is you cross your charges. Or I could ask you to write your product. And what you should realize is that this really forces you to understand what's going on. I might even, later down the road, put Na2O, NaOH, and ask you to fill in the water. So it's really just making sure you're familiar that a base is a metal that is bound to hydroxide, and know that in order to create these two things, whichever I'm asking you to create, you've got to cross your charges. I'm going to go back to this original problem, and what you should notice is that I'm not balanced yet. I've got 2 NAs here, I've got 1 NA here, so what I need to do is put a 2 right there. I've got 2 O's now, and what you should see is I've got 1 O here plus 1 O here, so I've got 2 O's, so I'm good there. I've got 2 H's here, I've got 2 H's here, and now I'm finally done. For number 2, again, this is flipped. Normally I gave you the 2 reactants and asked for the products, but now I'm giving you the products, one of the reactants, and saying figure out what the other reactant is. So before you freak out and say, oh my gosh, I can't do this, this is impossible, what you should realize is that I had something plus Na to give me NaBr. And so this is going to be a 1A because I'm obviously not creating an acid, which would start with hydrogen. I'm obviously not creating a base, which would end in OH. So this is going to be a 1A. And what you should also realize is that NaBr, what I'm forming, obviously I need Br to be on this side so that I can combine Na and Br. Now the reason why Br isn't before Na, guys, always remember whenever we write in an ionic compound, the metal has to go before the non-metal. And so that's just convention. Normally I have the Na before the Br, so that's probably why people are freaking out a little bit. Now, the important thing for you to realize, because I kind of bamboozled you a tiny bit, remember that Br is one of my diatomic elements. Remember, your diatomic elements cannot exist by themselves, so if I ever write them like just O with nothing else attached to it, I've got to write it as O2. I've got to write nitrogen as N2. There's 7 of them. Br is Br2, which I'll do in a second. Iodine as I2. Chlorine as Cl2. That is 5. I've got H2. That's 6. N2, Br2, O2, N2O, and F2. Okay. And so this has to be Br2. It can't just be Br because it can't exist by itself. Notice, however, I don't need to put a 2 here. That might be a misconception of some people because it's bound to Na, so it's not by itself. So now all I have to do is balance, which is super nice and easy. I've got NaBr here, so I'm going to put a 2 here because I have 2 Brs here, so I need 2 Brs there. Now I've got 2 Na, so I'm going to put a 2 in front of that Na. So really, really, really easy to do. You just kind of have to use your brain a little bit. For the NaBr, the way that I got that originally, if I were to do the reverse reaction, which is what we've been doing before, if I did Br2 plus Na to find out what it would make, what you should realize is that in order to make that compound, I have to cross my charges. So Na has a +1 charge. Remember, the metal goes first. Br has a -1 charge. So when I cross my charges, it just becomes NaBr. So that's why it doesn't have a Br2. It doesn't need it, and it would be wrong because they both have a charge of 1. All right, last one. Oh my goodness, that is actually a question the way that I showed you guys how to do it. So in this one, I've got a non-metal with oxygen plus water, and so this is going to be a 1C. And as I said before, this is going to be a balance as you go. So to do that, you put hydrogen first. And this is the only time, and I'm going to repeat this so many times and yet people will still do it, this is the only time where you can balance using your subscripts. So here I've got hydrogen, I've got 2 of them, so I'm going to write H2. Then I'm going to write my non-metal, which is carbon. So I'm going to put carbon here. I've just got 1 of them. And then for oxygen, I've got 2 here plus 1 here, so that's CO3, and I'm done. So notice for 1C, I don't have to cross my charges at all. You can't, in fact, because this is a non-metal and a non-metal, you can't cross charges. While for 1 and 2, for A and B, you have to cross charges to create the compounds. You have to cross charges here, you have to cross charges here, and here for 1B. So just keep your head straight, and what I would do is go back over problems that we did in class and make sure that you understand it, rewrite them without the answers, and see if you can complete them without my help.